Now let's work through an example of finding the normal of our equation y equals x to the 4 minus x squared plus 2x at the point when x is equal to 0. So for our normal, we're going to need to know our equation of the normal, which is y equals 1 over the derivative at our point, outside of x minus our point, plus our function value evaluated at that point. So our first step is going to evaluate when x is equal to 0 of our original function of y. So y of 0 is equal to 8 outside of 0 to the 4 minus 6 0 squared plus 2 times 0. So our 8 times 0 to the 4, 0 times anything is 0, even by itself is 0, so that's going to be 0. Same reason for that one, same reason for that one. So our equation for y of 0, when x is equal to 0 that is going to be equal to 0. So that's nice and easy and simple when we have to first try and find our function value. Next is going to be finding our derivative, which is given when we have a function in the form of kx to the n. Our derivative is given by kn x to the n minus 1. So what we're going to do is find dy dx, which is going to be 8 remains from our original. The 4 comes down, so it's going to be times by 4. X to the 4 minus 1 is going to be equal to 3. Our minus 6 remains, so minus 6. Our 2 comes down, so that's going to be times by 2. X, 2 minus 1 is going to be 1, so we just leave that as an x. Plus, our 2 remains. The 1 comes down, so we'll end up with times 1. And our x to the 1 minus 1 is going to be equal to 0, which is just going to be 1, so that remains. So that gives us our derivative of 32 x cubed minus 12x plus 2. Now we just need to solve this derivative. When x is equal to 0, dy dx is going to be equal to, well, 32 0 cubed minus 12 times 0 plus 2 is going to be, well, 0 times anything is going to be 0. So our derivative is just going to be our last component plus 2 or just 2. So now we've got our derivative and our function value at that point. We can just put it into our equation for our normal now, which is given by y equals minus 1. Our derivative at the point when x equals 0 was 2. X minus, well, our x value was 0, so minus 0. And our function value at x equals 0 is also 0. Now to simplify this one, we're going to have a minus 1 over 2 times by 0, which is going to be 0, and we have a 0 here. So our only component is going to be our first part here. So our equation for our line, our normal line, is going to be minus 1 over 2 x. So let's look at this on a graph. Our black line, which is given by the y equals 8x to the 4 minus 6x squared plus 2x. And our red line is our normal, which has the equation of y equals minus a half x, and we're looking at this when x is equal to 0. So that is our equation of our normal at the point when x is equal to 0.